In order to fully understand how evolutionary biology has linked with the history of the Earth and resulted in this amazing complexity we have on the planet, a very useful approach is to consider how a scientist views the Earth on which they live and how the scientific mindset is actually structured to move forward to deal with the amazing complexity that we're surrounded with on a daily basis. One of the first thoughts is that as you look around and see nature and see your surroundings, see society, that a scientist would say, first of all, that it's understandable. At some fundamental level, no matter how complex it gets or unpredictable it seems, we can't understand it at some level. So I look at it, I like to say that scientists are actually quite optimistic people instead of pessimistic, because they do see possibility even in what some people would call the impossible. Another scientific view of the world is that the ideas of your world, of how you view it and evaluate it, are going to change. So there's not a definitive truth that will be anchored once it's established and stand the test of time. It will stand the test of time in terms of being evaluated, but it won't be the end answer, because science will always be moving forward and finding new frontiers. This whole idea that scientific endeavor then, once you apply it to these complex surroundings you're in, it's the idea that the work that is done, even though it will change, that specific body of work is durable, or it's something that can withstand the test of scrutiny. And that's an important idea here, because a scientist would want their work to be absolutely excellent and rigorous. And, but there's also a knowledge is that as technology advances and concepts advance, that the field will move forward. But whatever you do accomplish can always be gone back to and be defended and argued as relevant and real. Another thing that a scientist would have deeply implanted is the idea that you can't have complete answers to everything. You can get partial answers, and you can get very well-established responses to questions that you put together via experimentation or observation, but you will never have every single answer. And that's something that society doesn't like. Society likes to have lots of answers. Fundamentally, science has to be both reproducible. In other words, no matter when and where and who does the work, if the same approach is done, that it'll reproduce the same results. So science has to be reproducible. But also another litmus test of the efficacy of science is that it has to be predictable. In other words, you have to be able to make predictions in the future of what might be happening in natural or social or environmental phenomenon. So there must be reproducibility and there must be predictability. And if those aren't engaged, then the scientific result is inadequate. Another thing that's really important, people think of scientists as automatons almost, and people who are shedding every part of their humanity to be a scientist. And I would argue that it's actually the opposite, that science depends on people who are imaginative and clever, daring, willing to do things that people haven't done before. All the aspects of human nature that I think are some of the most beautiful to capture all need to be embodied in the scientific endeavor. So far from being robotic, science needs to bring forth the best in people, and it's a truly human endeavor in that way. And because science is completed by humans, then of course, along with the strengths of humanity, like I said, courage and vision, there's also all the weaknesses of being human. There's bias, there's inconsistency, there's tiredness, there's frustration. And so all these factors come into play to describe and constrain the way that a scientist would want to approach what they're doing. Now, this is probably best expressed in a simple look at what are some of the end members or some of the spectrum of scientific approach. The list I just gave, it sounds good, but then how is it actually coming out in terms of the application and the end result of scientific endeavor? And so one of the ways we look at this is that one end member we call reductionism, one end member we call holism, and there's actually a third variability that runs right down the middle. So let me just explain to you. Reductionism has been practiced in science really since its founding. And it's the idea that, well, If you use your powers of observation and use the latest technology, you can identify what the individual pieces are of something that's complex. So if you had a car that didn't work, and let's say that the carburetor was bad, and you went to a garage that said reductionist garage on the top, then the mechanic in that garage would have you bring in the car, ask you what was wrong, and then that mechanic would say, okay, well, to understand your problem, I'm going to take your carburetor out, and I'm going to take all 3,746 pieces and lay them on the table. And then once I lay them all on the table, I hope I'll see something that gives me an idea how to put it back together. Well, that's a valuable approach. It gives a lot of information, but I think that all of us might be a little weary of spending a lot of money for someone who's going to have 3,700 plus parts sitting on a table and may or may not know how they fit together. The other extreme is called holism, and the holistic aspect is that someone would say, well, bring your car here, and I'm going to look at all the parts. I'm going to start with the bumper and the fender and the hood, and then I'll get to the carburetor, and then I'll have every single part kind of understood and put together in a very generalized sense. But I'm not sure always that we're going to know what all the individual pieces are. That would make me equally nervous, right? I think to be really good at fixing an exhaust system is a different set of tools than fixing the carburetor. So I'm not sure I would want to go to the holism garage as well. But there is one repair shop that I like to plug into on a regular basis, and I think this is the one that gives a lot of strength to the approach of studying evolutionary biology, and that's the middle path between the two. There's a mantra or a statement that somewhat encapsulates this, and it's that the whole is greater than the sum of the parts. So in other words, the best way to move forward now is to use a blend of reductionist and holistic approaches. And the way to do that is you'd want to carefully pick the few detailed parts of the system that you know will have relevance and importance in terms of how the system works. But you're not going to describe and analyze every single part. And at the same time, you want to understand how that part fits into the whole. And so you won't want to have just a carburetor, but maybe there's some kind of back pressure coming from the exhaust system that's preventing, efficient firing in the cylinder. So you do need to have some idea of how the system works. And this idea of system science is very important now, and it's moving forward. So the middle path is what we're after in this kind of scientific endeavor to truly understand the manifestation of evolutionary biology in the context of the history of the Earth.